Okay, so here is a lesson on charging by contact. It's the second formal lesson of the electricity unit of the grade 9 science curriculum. So to begin, the first thing we talk about is the idea of charging by friction. And we have done this already in class. Physically we've done it. We've charged what we call ebonite rods by rubbing it with rabbit fur. And so charging by friction, of course, is when you have two uncharged objects. That rub against each other. That would cause friction. But when you create an electric charge by friction, it turns out that one of the objects takes electrons away from the other one. So we've done that a few times manually, as I said in class, and the result then, since one object takes electrons from the other object, you end up with one object with a positive charge because it has given away electrons, and one object negative because it has accepted electrons. And so then the question becomes, how do you know which one's going to become positive and which one's going to become negative? And the answer lies in something called the electrostatic series. And I think it's important, you can see I have a list here, to understand, first of all, that this is it's a sample list of the electrostatic series. The series itself could be, quite honestly, thousands of lines long, because it could list any materials, and certainly studies have been done on sort of, like I said, thousands of different materials. So this is just a sample of the list. The list is very, very specific in that it's ordered by how much it wants to give up electrons and how much it wants to take electrons. So if you have a material near the top of the list, and this is just a sample list, this wouldn't be the top of all objects that exist, but in my list, human skin is the very top of the list. And what that means is it's the most likely to give up electrons. So human skin, most likely of all these objects to give up electrons. Whereas ebonite down here, we've used ebonite in class, is the most likely to take away electrons. And so what that means is that by rubbing two objects together, for example, say ebonite, the one we do in class all the time that works quite nicely is ebonite and rabbit fur. And if you rubbed rabbit fur and ebonite together, you would end up with positively charged rabbit fur, because it's going to give away its electrons to the ebonite, and the ebonite ends up negative. And that really in grade 9 science is the most common example. But there's several other examples here, and these are mostly objects that we have used in class as well. So like I say, the electrostatic series is really any object you can think of would find its place on this series. It's just, this is just a sample. So the electrostatic series in general in order of how much. How willing they are to give away electrons. And something that might be intuitive to you or may not be, is that if you take two items, say I take cat fur and wool, and I rub those two items together. Well, if I rub them together, it's possible that the wool will give up some electrons to the cat fur, But in practice, the further away you are on the electrostatic series, the more successful you're going to be in creating electric charge. So the ones at the bottom are really going to want to take away electrons, and the ones at the top are really going to want to give them away. So you're more likely to get more electrons passing, you get more of a noticeable charge. In the class I had a good question, which is, why is cat fur and rabbit fur different? And my answer, unfortunately, was that I don't know exactly, except to say that really it's a function of its chemical formula, and cat fur and rabbit fur would have subtle differences, and those little differences in the chemical formulas for them would result in how much they want to give away or keep electrons. So moving on to the example here, oops. The example just says, imagine, spelling mistake, you rub a filled rubber balloon on your head. Predict which of your head or the rubber balloon will be positive and which will be negative. So the two choices are balloon and hair. We'll say human hair. And then if we go back to our electrostatic series, our series has them all on there. So human hair is fairly high, and it looks like human hair wants to give up electrons, and balloon down here, here's my balloon, oopsie, balloon will want to take electrons. So that must mean the balloon is going to become negative, and the hair will become positive. Okay, so the next topic along the idea of charging by contact is something called conduction, and conduction, conduction is actually touching. So charging by conduction is just actually a short physical contact, unlike rubbing, which is sort of actually physically pulling the electrons off. Conduction is just a short physical contact, short duration. Okay, so how to charge by conduction. Earlier in a previous lesson, we saw this, my little gray picture here, which is supposed to represent a negatively charged ebonite rod, and you should notice again that it has more positives on it than it does negatives. Therefore, I said that wrong. It has more negatives than positive, and therefore it's negative. And a neutral sphere, and we drew this previously as well. A neutral sphere might have, well, it has billions and billions, but we're going to write down 7 protons. 7 times a billion, maybe, but 7 protons, and it's going to have 7 electrons as well. But the thing is that, similar to what we learned with charge separation, as soon as I bring this negative close by, my 7 electrons are going to scooch over to the side to get away from my negatively charged sphere. No, negatively charged rod, I mean. So now I have a negative side and I have a positive side. So what happens is, as I bring this closer and I actually touch the electrons on here, these buildup of electrons here, they're going to see this empty space where there's no electrons, only positive, and the electrons here, upon contact, are actually going to jump over. So upon contact, now, typically, that contact, the duration is not quite long enough, and because it was negatively charged to begin with, you generally end up with the rod still being negative, but the sphere being negative as well, because now it's going to take on, say another even 3 or 4 extra electrons, right? So now this has more negative than positive, so it's negative, and so is the rod. So the end result then of charging by contact is 2 objects with the same charge. And if you do this, and hopefully you will get to in class, you can try this with our little pith balls. And what you'll see when you bring the pith ball close by, and you have your pith ball hanging there on a thread, you bring the rod close by, the pith ball will typically jump towards the rod because of the charge separation. So because of the charge separation, here at the very beginning, where this side is all positive, the sphere will actually jump towards the rod before you actually bring it in to touch. And then as soon as it touches, it becomes negative, this stays negative, the sphere jumps way far away. And that's what you should see, and that's just showing you that it's attracted at first because of this positive side over here on the left, and then as soon as it happens, the negatives jump quite quickly over, and now you've got a negatively charged sphere repelling from your negatively charged rod. Okay, so the final thing we'll talk about is a fairly generally known concept called grounding, and this is the electrical symbol for grounding. And grounding actually means what it says. You create a physical contact through an electrical conductor, like a wire, to the ground. To the earth. And the idea behind grounding is that the earth is so huge and it has such an excess of charge, it's neutral, but I mean it has so much room to take charge, I guess is what I mean to say, so that if you had a positively charged object, you know, the earth could easily give away. So this is earth, and here's your charged object, right? Here's my object, and it's all positive. Well, if I could connect this through a ground wire, and really, like I say, the symbol would be this. That symbol means that it's grounded. If I grounded it, what would happen is all these extra electrons on the earth would jump through my ground wire up and neutralize whatever object it is. So grounding, and the same case would be if it was a negatively charged object. The negatives, the electrons, would actually just shimmy through the conductor to the ground. The earth is just so big that adding or taking away any extra just doesn't influence it. Keeping in mind that earth is so much more massive than any objects in our experience, our personal experience. So we ground because we don't want built up charge. You experience this quite frequently, and you see it quite frequently. If you look anywhere, certainly in the lab room, all of our taps, all of our electrical conductions, every connections are all connected to ground, and that's a safety as well. We'll talk a lot more about grounding later in the course.